Hello, and welcome to the video guide for our SolidWorks workshop. My name is Jack. I'm a senior in the Biomedical Engineering department with an additional major in Computer Sciences, and I will be walking you through our introduction to SolidWorks. Before we begin, I just want to talk a little bit more about software training for students. We offer a variety of resources for you, all for free. For example, we offer workshops in College Library as well as the new Morgridge Hall. We offer those in person at the beginning of the semester, and then we gradually transition to hybrid and virtual workshops throughout the semester. We offer free one-on-one appointments as well as office hours, both in College Library and Morgridge Hall, and you are also able to request custom workshops for your classes, organizations, or clubs. For more information, you can find us at sts.doit.wisc.edu. To begin using SOLIDWORKS, you will need to either log on to a computer-aided engineering or CAE lab computer, which can be found at cae.wisc.edu under the Labs tab and Lab Locations. SOLIDWORKS is a Windows-only software, so please only log in to a Windows computer listed at one of these locations. If you prefer to work locally on your own Windows computer, you may also download SOLIDWORKS through the campus software library. That can be found at apps.software.wisc.edu, and you will land on this page. From here, we're going to scroll down and find SOLIDWORKS by Default Systems and click into this page. From here, we can expand SOLIDWORKS and then whatever year we are right now. So this version is SOLIDWORKS 2025. Please note that if you are not currently connected to UWNet or EDU-Roam, you will need this serial number in the installation process in order for SOLIDWORKS to install correctly. So from here, we're going to download the file. We have to agree to this terms. Just so you know, this is an educational license, so you are not able to create commercial products, and that is why the software is free for us, free to learn how to use it in an academic setting. So we accept the terms, and our file is going to download. From here, you should open the file and install the software. Eventually, you will need this serial number activation. Please copy and paste this into the installer, so that way it is able to continue. From now, we are going to assume that you either have SOLIDWORKS installed correctly or you have logged on to SOLIDWORKS through a CAE computer at a computer lab. One final aside before we jump into learning SOLIDWORKS. Currently, there is an option to remotely run SOLIDWORKS through your web browser on a CAE computer. Currently, that URL is remote.engr.wisc.edu, and you will be able to log in with your CAE username, and then you should be able to launch SOLIDWORKS from here. I do not recommend this though, because you tend to run into a lot of bugs trying to run a desktop piece of software through the web browser. So I would recommend you either download SOLIDWORKS on your computer completely, which if you run into problems or difficulties, reach out to STS and we will be able to help you, or the CAE help desk more likely, because they are able to troubleshoot installation and licensing problems. Or I recommend you just go physically into a CAE computer lab and log on. When you first open SOLIDWORKS, you will be greeted with a screen that looks like this. Yours will probably not have any recent documents below, but other than that, it will look very similar. Here, we are able to select if we want to create a new part, assembly, or drawing, as well as open a previous file, or view recent folders. We are going to start by creating a part. So if we click the part icon, SOLIDWORKS will now load in the background. and we will be greeted with the SolidWorks home page, essentially. Here in the middle, we have the origin. On the top, we have a top bar ribbon with different tabs. Right now, we are inside of a sketch, and we are looking at basic modeling tools. This SolidWorks CAM, CAM-TBM, simulation, analysis preparation, and COMSOL multiphysics. These are all add-ins that you may or may not have installed. For now, you are going to spend most of your time in basic modeling tools. Depending on which mode you're in, more or less of these options will be grayed out. And as we will talk about a little bit more later, most of the options on the left here are for 2D modeling, and then on the right here are for 3D modeling. On the bottom right, we have a unit selector. This is important because when you're creating your model, you want to know what units you are using, whether that be in meters, centimeters, millimeters, or inches. It conveniently also sets 2 other units at the same time. It allows you to set your weight measurement as well as your time measurement. Most of the time, you will probably be in IPS, or inches, pounds, and seconds, or MMGS, millimeters, grams, and seconds. It's totally up to you what you decide, but always make a habit of checking this at the beginning of each of your modeling sessions, just so that you're aware of the scale of your device. I'm going to leave mine on inch, pound, seconds for right now. On the left, we have a feature manager. This is where you're going to see everything that currently exists in our file. You can see that we have 3 different planes that we'll get into in a second, and an origin. Here are some other options. So right now we have our feature manager design tree. As we add more and more pieces to our model, you will see that this blue line moves down, and you'll see what we're doing being added on here. If you want to go over here into Property Manager, this is where you can select a sketch or a body and then determine certain properties about it and change those as well. If we move up here into Configuration Manager, this is where you rarely go, honestly. You are able to change some of the display states, but you will rarely find yourself in this menu. Same thing with this Dimension Expert menu. You may or may not have this installed. Display Manager is where you're able to alter the appearance of your material, so that way you can get a more lifelike model in SolidWorks if you're taking pictures, for example. And then here we have our CAM feature tree and 2 other CAM tools. Again, those are add-ons that you will not have to worry about right now. For now, navigate back to this main feature manager and make sure that you are looking at these 3 different planes with the origin in the center. And now, once we have this beginning understanding of SolidWorks and what it looks like in the main menu, we are going to begin creating some of our models. Let's begin with starting to make our first part. The general dogma of using CAD software or computer-aided design is that you begin with a 2D sketch and then you extrude or basically push and pull that 2D sketch into 3D space. So let's begin with doing that. One final note is that you should have an external mouse when you do this, because we're going to be utilizing both left click and right click, as well as the scroll wheel and pushing down on the scroll wheel, which is incredibly difficult to replicate on a trackpad. So let's go over how we can start our sketch. Now that is what we call our 2D representation of our object. So in the top left here, if you still see Exit Sketch, go ahead and click that button so that way it turns into just normal sketch. When I click Sketch, I will now see where I have front plane, and then it looks like I have 2 other planes here because I do. So this is where that external mouse is going to come in handy. We're going to take that mouse and press the scroll wheel down, and that's how we rotate and basically hold our object in our hand and spin it around so that we can look at it in all different directions. So when I let go, these names will populate. So we have a front plane, right plane, and top plane. So now which one you pick all depends on what object you're going to create and what order is easiest for you to create it in. So for right now, we are going to create just a simple rectangle box just to show you the method. So honestly, we could start with any plane, but the easiest I think for us will be top plane. So let's click top plane. And now just to help orient yourself, we are looking at the bottom left here. You can see that it says top because we're looking at the top plane. And you can see our coordinate axes here. We have an x-axis going to the right, a z-axis going down, and then we're actually staring straight down through the y-axis. Now, technically, you could create this object in any way that you would like, but by adhering to what SolidWorks recommends for this top here, if we use some more of these menus up here, which we will discuss later, you are going to be able to read and say, okay, this is the front, this is the right, this is the back, and those will accurately correspond to your model. Again, don't worry about that too much now, but just in case you're curious about why we picked the top plane, it's because we're just going to make sure that we are keeping in alignment with our naming convention here. So great. We have our sketch now looking at the top of our object. So let's go. We're going to make a square. So I want to start with the rectangle tool. And you notice a lot of these tools have a little caret down or a little arrow down. That means there are other options. So let's start with a corner rectangle. When I click here, you can see that my selection on the left has changed, and I can change exactly how I create my rectangle. So I can create a parallelogram here. I can click in the center and then click a corner, or I could click two corners. So I'm just going to click two corners. When I do that, notice how when I have just varying dimensions of this rectangle. So one of the ways that we're able to determine exactly what size our objects are is by using our tool called Smart Dimension. Now this is going to become probably your favorite tool in SolidWorks because of everything it can do. So what we're going to do is click Smart Dimension, and then you can see our cursor has that little dimension box next to it. I can go ahead and click on one of our sides, and 3.45 is what it says. Now what does that mean? Because our units are in IPS down here at the bottom, inch, pound, seconds, it is saying that our side length is 3.4542 blah, 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 blah inches. But let's say I don't want it to be that. Let's say I want it to be 10 inches. Once I clicked with Smart Dimension, it popped up this box. I can go ahead and type in 10 and click Enter. Now notice the label changed to 10, but it doesn't look like our scale changed. That's just because SolidWorks auto-zoomed for us. So if I go ahead and now click here, you'll see that now this is 11.63. Let's go ahead and make this 10 as well. And now we have a square. That is the basics of using Smart Dimension in order to determine and tell SolidWorks exactly what size we want each of our sides of this rectangle. Now, we can go ahead and let's talk about Smart Dimension with one other shape. So now is a great time to talk about another movement feature in SolidWorks. We already discussed that if you take your middle mouse button and press it down, we are orbiting. Now let's talk about pan. Pan is if this is on a sheet of paper and I'm just sliding the paper to the left. The way I do that is I hold the control button and then press the mouse button down, and then you'll see the pan icon, which is that four-headed arrow. That's just like our design, again, is on a sheet of paper that we're sliding over to the left. Now let's go ahead and try a circle really quick. So in our circle, we have multiple different ways to create a circle. The easiest one is normally you click the center and you click the outer edge, or you could create a perimeter circle. Let's go ahead and stick with a center-based circle. Go ahead and click the center, and then I can just drag. Now, just something important to keep in mind with circles specifically is that SolidWorks will alternate using radius or diameter to define a circle. As you can tell right now, it says r equals. So that means our radius in this case is pretty close to 5. So let's just go ahead and click here. And once again, we're going to use our favorite tool, Smart Dimension, to go here. Now notice I don't have r equals. This little circle with the slash through it means diameter. So the diameter of our circle right now is 10.43 inches. Let's say we just want it to be 10 inches. And there we go. Our diameter is 10 inches. Again, just something to keep in mind if you're dealing with radius or diameter. And in the future, this symbol right here is what SolidWorks uses to confer diameter rather than radius. So from here, you can continue building whatever you'd like in 2D before you move on to 3D. Some other things that I recommend you experiment with are lines. You can do a center point line, a midpoint line. You can use polygons. Different types of arcs will also be useful, as well as spline. If you want to create a curvy pattern, I recommend you use the spline tool and just play around with how these tools work. Once you feel satisfied with your design in 2D, then we're going to move on to extruding it into 3D using the tools that are not grayed out now in basic modeling tools. And we'll do that in the next part. Now that you've created the sketches that you are satisfied with, you can see that we have a new sketch, or in our case, sketch 2, on the left of our feature manager. Let's say before we want to extrude any of these shapes, we want to edit them. What I can do is right click and then go back to edit sketch. Now you can see our smart dimensions popped back up, and we can confirm our specifications of our design. But now let's go back and exit out of our sketch. And now you can see that if we take our middle mouse button, our middle mouse scroll wheel, and we press down, you can see that now we're rotating in 3D space here. So let's say that I'm here and I'm completely off, and I really just want to get back to a set view before I start doing anything. I love this little top bar in the top here, and if you want to find view orientation, you get this very handy cube that has all these clickable planes here. I like to find one that is looking straight down on my model, so that way I have an easier time identifying what's going on. So great, we have our sketch that is complete, and now we want to turn our 2D sketch into our 3D object. So let's go ahead and do that. For this, we are just going to use basic extrude boss base, which is taking what we drew and just pulling it up out of the page or pushing it down into the page. That's the general idea. So if I go to extrude boss base here, we get this message. We need to select a plane, or we need to select an existing sketch. So if I go ahead and click one edge of my square, you can see that my view is now shifted and my square is yellow. Now this little arrow here means that I'm going to extrude or create this object into 3D space going this direction. The great thing is you can actually click and drag on this arrow, and a virtual measuring tape appears right here and tells you approximately how much you're going. Again, we can always change this number, but it's just helpful for scale for you to see. So I'm going to go up and just drag it here. Again, let's use that pan function where we hold the control key down and take our scroll wheel and push down on it so we can move up a little bit more. Now let's go to the left and look at some of our options and explain what they're doing. Here from sketch plane, that is where we're starting, and then we can, of course, flip which direction we want in, which direction we're extruding, and then based on if we want it blind, which means however much I set right here in depth, it will do, even if that's cutting into another object. For right now, we're going to leave it as blind. These up to vertex, up to surface, offset from surface, all of those you're going to use with more complex designs. For right now, this number right here, where it's our depth, that is our version of smart dimension in 3D. Now, in that sense, that means if we change this number, that is how we change the size of our 3D object. So if we remember back, we had a 10-inch square and a 10-inch diameter circle. So if we want to make this a cube, we're going to change 8.71 to 10 inches. From there, we can just click out, and you can see now it's previewing what it would look like. And go ahead and click accept. And now it's solid. So notice that now my sketches disappeared. So the way that we're able to get that back is our sketch actually became a child object of our boss extrude. That means if I hover right here, we are able to see that my two sketches are still here. But because I have extruded one of them, they all now disappear. So let's go ahead and let's extrude our other sketch, which is our little circle here. So if I go back and I click here, I can see the smart dimensions that we had. So we did in fact have a 10-inch cube because our boss extrude is 10 inches now. So this is a helpful way. If you click on these two objects, you can see the dimensions to confirm what they are. So that way we know we have the correct model. Now let's go ahead and extrude our circle. If your sketch is not appearing underneath your cube, here's how you're able to do that. Let us expand our boss extrude here. And you can see sketch 2 underneath. We are going to right click and make sure that our sketch is shown, because before we were unable to see it. So let's right click and make sure we click the eye to show. This is how we're going to be able to select our circle to be extruded separately from our cube. So now I can go to extrude boss base. All I have to do is click on my circle, and now you can see that this is how it's going to be extruded. It does copy the settings from the last extrude, so it does suggest 10 inches, but we can easily make this 15. Click out of it or hit enter, and you can see that 15 has been updated, and we can confirm that yes, that cylinder is now taller than the cube. Again, blind is perfect for us, but let's say we just want to flip it and extrude it down, which we easily could. We could then go ahead and click the check mark, and now you can see the face of both of our objects are in the same plane here in the center, but then one is extruded up 10 inches and the other one down 15 inches. Now, you can see that because we did this boss extrude twice in 2 separate runs, the sketch here is actually shown twice, and the boss extrude reference different objects here. So just keep that in mind. Moving forward, if you do have one sketch and then you extrude multiple objects individually, you will see a bunch of copies here. And now finally, before we jump into our walkthrough project and conclude this introduction part, let's just talk about this blue line here. This blue line allows you to basically travel back in time and show what happened in the order that you did it. So let's go all the way back here. This is where we started, and then we created our sketch and then extruded it. It does sometimes not like only showing the sketch instead of the extrude. That is one weird thing here. I recommend you don't do this. I recommend here you just come here and you just hide the extrude. That is going to be your easiest method of making this work. And then if you want to go back in time, but for now, let's just right click, show our cube again, show our cylinder, and we're very happy. One quick thing I do want to say is let's quickly talk about saving. What we're able to do is go up here and do File, go to Save As. I always like clicking Save As. And then here, we want to save it to our downloads, our documents, or desktop, whatever you think. And the key thing to be aware of here is if you want to 3D print this model or edit it in a different program, you are going to want to save this file as a .stl file. Now be aware though, if you save this as a .stl, it will make it incredibly difficult to edit it back in SolidWorks. So what I recommend is until you are confident you are done with your design, keep it in a SolidWorks part file that is a .sldprt, a solid part. So you can name it whatever we want. I'm going to name it intro part. We want to save as. We can go ahead and click save, and you'll notice we have intro part up here. And anytime there's an asterisk next to this name, that means there are unsaved changes. But for now, continue to play around with extruding and creating your different sketches and extruding those sketches up and down and just playing with the introductory features here so that we can get your 2D sketch into 3D. Following this, we are going to walk through an example project where we are going to make a few chain links and then assemble them together to discuss the assembly feature so that way we can talk about more advanced parts of SolidWorks. So please take all the time you need to practice this, and then in the next section we will go ahead with that walkthrough and follow along workshop. Now that we went through an introduction to SolidWorks, let's go through a guided project together to walk you through creating different parts, assembling them in an assembly, and showing off your SolidWorks skills. Let's now go ahead and create a new part. In the top left, click on File, and then click New. We want to create a new part, and we will create multiple parts to then assemble together in an assembly. Let's click Part and click OK. Now that we have our new part file, let's confirm our units in the bottom right. We want to be in IPS, inch, pounds, inches, pounds, and seconds. So our project is going to be creating 4 different sized chain links and then in an assembly mating them together so we can create a circular-ish link of chain links. So to begin, we want to create a 2D sketch from the top plane. So how do we do that? Well, let's go up to the top left, exit our current sketch. Let us create a new sketch. Let's orbit around and let's try to find our top plane. Now remember, to orbit, we took our middle mouse wheel and we pressed down on it in order to orbit. So now let's click on our top plane. Now we want to create the general shape of a chain link. Now for ease of this tutorial, we're going to use a preset option that SolidWorks has. So instead of trying to fight with making a rectangle and then adding 2 hemispheres, one on each side, there is actually a tool called the Straight Slot tool. So what I like to do is go up into Commands. If you're on the CAE computer, it still should generally be up here on the top. We're going to look up straight, S-T-R-A-I-G-H-T, straight slot. So one of the great things about SolidWorks here also is if you want to learn where some of these settings are, once you select straight slot, you can actually go over and click Show Command Location. And if you do that, it will actually open the menu and move your mouse automatically, and then do that nice little red arrow right there to show you where it is. So if we want to reference it again, we can do File, Tools, Sketch Entries, Straight Slot. Perfect, let's do that. So on the left, we can see the way that we're going to create our slot. We want a straight slot, so not one of these two curved ones. And let's do it with the two centers of those hemispheres almost, and then just an outside thickness. So let's go ahead, and it normally is helpful to follow these dashed horizontal lines, so that way we can keep our design straight. So let's click one, let's just click on the other, and then let's make it some thickness. Now again, we don't really care what these dimensions are right now because we have our lovely friend Smart Dimension. So what you can do, either use Smart Dimension to click on certain properties here, or you are able to mess around with the parameters here on the left. For me, I still love Smart Dimension, so I'm just going to go ahead, take Smart Dimension, and directly edit exactly what I need. So I want the length of our chain, excluding the hemispheres here. I want this length to be 7 inches. Great, and remember, even though it looked like our scale didn't change, it did in the background, so don't worry. This actually is 7 inches now. Let's say I want this distance between this point here and this point here to be 1 inch now. Great, I just clicked those 2 points, click 1 inch, and boom, there we are. So now we have part of a chain link. Now, one of the most important things of one of the most important parameters or parts of a chain link is that you can actually link them together. So let's make that little hole right here and on the other side so we can link them together. So the way we're going to do that is let's take our circle tool. I like to use the tool where we select the center and then the outer part of the outside of the circle here, and let's just plop a circle there, and let's plop a circle there. Again, not too worried because we're going to change those dimensions. So let me go into Smart Dimension now, and if you follow along, let's start with the left circle, just for example. Now remember, this circle with the slash through it, right to the left of my cursor, means diameter. So I want to make the diameter of this circle 0.5 inches, and I want to do the exact same thing for the right. So we got pretty close at 0.51. Let's just set it at 0.5 right now. Fantastic. So now we have a sketch of our chain link. So if we go to Exit Sketch now, we can see our completed sketch here. And now we want to extrude our chain link. So that means we're going to take this sketch and we're going to extrude it. So let's take Extrude Boss Base, and SolidWorks already identified that we have a larger sketch, which is the outside of our chain link, and we have 2 inner sketches, that circle there and that circle there. And it's smartly identified that we do not want to extrude the center parts, but we want to extrude everything else. Most of the time, SolidWorks does correctly assume this, but if your instance did not do that, what you may have to do is select the edge of our part to select just the inside here. And if for some reason you're only selecting the circle, you may actually have to click Selected Contour here, click X, and then try to add it again, and you'll want a reddish color on the contour that you're selecting. For example, like this, you would click that, and then you would have the correct contour. Now that we're back into this menu, let's go ahead and change 0.1 inches, and let's change that to 0.25 inches. 0.25 right there. We can click enter, and we can see that our preview has adjusted accordingly. We've double checked that we're blind, and this is the direction that we want. Let's go ahead and click the check mark. And now we have our solid chain link right here. Fantastic. So once we've created this, let's go ahead and save this part. So let's go into the top left, File, do a good Save As. Let's name this Link 7 because this is our 7-inch long chain link. Because we're actually going to go and edit our previous design here to make a 6-inch long, a 5-inch long, and a 3-inch long link. So adding the length of the link in the file name will help us in the future. Let's go ahead and keep it as a SolidWorks part file and go ahead and click Save. From there, we are now able to go back and edit our sketch, and then our following extrusion will actually edit based on how we change the sketch. So let me show you what that means. If I go back to our sketch file here, we can see that this has 7 inches. Each of these are half an inch in diameter, and then the width of the link here is 1 inch. So if I go ahead and right-click here and edit our sketch, I can go ahead and let's say I want all of this to be the same, except instead of 7 inches, I want this to be 6 inches. And all I did was double-click on 7 inches right there. Go ahead and click the check mark, and our chain link magically shrunk. Now if I go ahead and click yes, and now if I go back out here, and then I exit sketch, our chain link is actually now 6 inches long. And that extrude, that boss extrude that we already did, adapted to the changed underlying sketch, which is fantastic. So to be honest, you could have made these holes larger, you could have shifted them, you could have made it wider. You can do a lot as long as that boss extrude is the parent of your sketch here on the left. And you can see that the sketch is nested underneath that boss extrude. That means whatever you do to the sketch, that boss extrude will then remain exactly what it was before you edited that sketch. So that's fantastic for us because we just made a 6-inch long link by barely changing anything. So we have that 6. Let's go ahead and do File, Save As. Let's name that Link 6. Perfect. Now let's go ahead and change it so that way it's length of 5. Let's go ahead, right-click on our sketch, edit our sketch, go ahead and double-click on our 6-inch smart dimension, change that to 5, shrink our link down, click yes, go ahead and exit sketch. Now we have our 5-inch link. Again, it's always good to just double-check by clicking on our sketch here, seeing that we still do have a correct 5-inch length. Go ahead, File, Save As, let's name it Link 5. And now finally, we're going to make the smallest link. So let's go back to Sketch, right-click, Edit Sketch. And again, here we might use our Pan tool or just zoom out. If we zoom out, we can also do Control and that middle mouse wheel, press that down to drag. So that way we're panning. If we took the sheet of paper and just pulled it towards us. Let's go ahead and double click on 5 again. And we want our last link to be 3 inches long. So go ahead and click 3, yes, exit sketch, and bam, we now have a 3-inch long link. Let's finally do File, Save As one more time, and do Link 3. Let's just capitalize it just for making everything the same here. Great, and you can see that I have link 3, 4, 5, sorry, not 4, 3, 5, 6, and 7 all in downloads, which we will need in the next part. So now we have taken all 4 of these parts. We've created them from one master template, which was our 7-inch link. Now what we're going to do is create an assembly and put all 4 of these links in together and then add some relations between them so that way we can get them to move in the way that we would like. So that's what we're going to do in the next section. Now that we've finished making our 4 models, let's go ahead and create an assembly of these 4 models. Go into the top left, File, New, and this is where we're going to pick Assembly. Now, as you can see in the note, this is an arrangement of parts, plural, and other assemblies. So we could create an assembly from 3 parts, or we could make an assembly from 2 parts and another assembly, for example. But in our case, we're just going to use those 4 chain links we created. So go ahead, click Assembly, and click OK. SolidWorks will now ask you which parts would you like to insert into the assembly. Let's go ahead and let's insert all 4 of our chain links. You will probably see the most recently saved one here on the left. Let's go ahead and click link 3, and then as you do that, you will be able to drag around your screen and then click one more time to place your chain link here. Now, this looks fairly similar to just the normal part creation process in SolidWorks, but now we need to go ahead and add all of our other links. So let's just keep in mind that this is our chain link number 3, so our 3-inch one. So let's go ahead and add our 5, 6, and 7. We're going to go up in the top left and click Insert Components. We've already done our 3. Let's go ahead and add our 5. Place that down. We've done 3 and 5. Let's go ahead and add our 6 by doing that. Same process. 6. Let's do it one more time. And there we go. Now we have all 4 links in our assembly. Now is a great time to go ahead and save our assembly. So let's go up and do File, Save As, and let's name it Chain Links. Now notice this file is saved as a solid assembly, SLDASM, just so that you're aware. Again, let's say you want to assemble some parts together and then 3D print that. That is when you would save this as an STL file down here. But again, for right now, we are going to stick with SolidWorks assembly file. Go ahead and click Save on this. Just something to be aware of. These link 3, 5, 6, and 7 files are not actually saved as part of this assembly. This assembly references those files. So if you are creating this assembly on a CAE lab computer and you want to edit it on your own computer or laptop back at home, you will need to transfer not only this assembly, but all 4 of these solid part files, those .sldprt files, or else you will not be able to edit the assembly, just so that you're aware. So at the end of this, you'll want to save this assembly and all 4 of these part files together. Perfect. So once we have that, let's go over one quick important note for assemblies. In assemblies, the very first object you insert is fixed. That means if we start moving any of these objects, the one that will not move is our link 3. And you can look at that on the far left. Notice how it has F here. That means it's fixed. So when we start using the Mate tool up here and we start attaching links to each other, notice that all of the other links will move, but this link 3 is fixed. That's important for later on, just so that you know. But just keep in mind that link 3 is fixed. Great. So let's go ahead and actually start mating these links together. So let's go ahead and choose the Mate tool from the top bar. And from here, we need to first think about how we're going to connect these links. So now remember, these links would be connected with a pin or a bolt going through one, then through another, and then attached with a nut on the other end. So if we think about it, we are going to have this bottom edge of this link here would be directly touching this top edge of this link right here. Now we need to be very careful because you can see how easily it is to accidentally select the entire inside here instead of just this top edge. So that is honestly going to be the key of how we're going to correctly mate these objects together. So let's zoom in. Now remember, this is our link 3, and it's fixed. So let's go ahead and click the ring, just the top edge of this link right here. And now we want to connect it to the bottom of this one right here. Now doing that, ready? So you saw that things moved. And now look, I don't know where I am. So let's go up and let's do this view orientation again, and boom. If I go like this, I can now see exactly what happened. So we were able to see that those edges were connected correctly. Fantastic. So I can get out of the mate function right now, and let me just click on to this link here, and then all I have to do is click and drag. So ready? I click, and then I just hold my mouse down, and I can drag. Click and drag, click and drag. Now, the only reason this works is that this 3-inch link is fixed, which means I can move this 5-inch link in any way that still works with the mate. Now, the reason we had to select these edges here is because these edges will touch no matter what orientation this link is in. Fantastic. So let's go ahead and let us try and add another link to this. So we're going to add this 7-inch link right here. Great. We're going to add that 7-inch link to the top of this link right here. So let's go back to mate. Let's click this ring right here, just the very top, remember? And now let's click the very bottom of this link. So right there, and perfect, things move. We're going to click yes, and now I'm lost again, so not a big deal. Go back up to view orientation, boom, I pop back to where I know, and let me just pick this view right here. Fantastic. So now let's get out of mate, and you can see that as I move this link, the other 5-inch link actually moves with it. But again, all of these links, these 3 links, are mated together with our 2 mates in this joint right here and this joint right here. And all of this movement is still compatible with those mates. And again, this is all resting on the fact that this link right here is fixed. So if we rotate to the side, we can see that if we attach this final link to the bottom of this link, and then if we actually attach it to the top of this 3-inch link, we should be able to get all 4 of them connected together. So let's go ahead and do that. So I am going to take the bottom of this link and let's attach it to the top of this one. Let's go back to mate, zoom in. We're going to click the bottom. Again, just be very careful that you click the bottom there. Perfect. I want it, take some little maneuvering here. I want it to attach to the top of this one. So let's go ahead, zoom in, click. Awesome. And look, oh, I was able to figure out where I am now. So go ahead, click the green check mark, move over. Let's get out of mate one more time. And boom, we can see that all of these are connected. Now, as you can also tell, physics doesn't quite work while moving this simulation just because SolidWorks isn't told that it needs to avoid collisions. But as you can see, it's able to freely move. So let's go ahead and fix this final link back here onto the front of this link right here. So now here's actually a little pro tip. Sometimes if this is crooked, as in if I tried to link these two right now, this edge would snap here and we would get stuck in a weird mess here. What I can do is actually change which link is fixed to help us get a cleaner attachment. So let's go ahead and actually fix this 5-inch link. So all I need to do is right click and click the fix button. Now those two didn't move and only these two can. So this allows me to ensure that I'm actually getting the correct edge, so I need to get the bottom of this and the top of this. So let's go ahead and we can float it. Now float is the opposite of fix, so let's go back to floating. Now I want to go to mate. Again, click the bottom edge of this link, scroll up, and click the top edge of this link. And boom, it was able to attach correctly. Awesome, let's close that, move over here, and you can see that we have kind of a parallelogram a little bit, you could say. Not quite, but an interesting shape here. So now let's notice how this moves. So I'm able to move this bolt, this massive 7-inch link, all around, but again, it has to be compatible with all these mates. So notice the more and more I turn it, the more and more it's actually wrapping in on itself. So just remember that physics doesn't always quite work in this viewing section right here. If you want to actually run a simulation, that's something we can actually help you with here at STS, as well as in computer-aided engineering. But that's where you can actually analyze force. So just remember, physics isn't always SolidWorks' great forte for right now. But let's go ahead and let's float our 3-inch link, and let's fix our 7-inch link. Now notice, I can move this, I can move this, I can move this, but I cannot move this link. So let's say we want to float everything. Now things get really weird because I'm not only moving it in the traditional XZ plane here in the bottom left, you can see I'm also moving it in the Y plane. So I'm moving it up, down, around, so there are no constraints on our object here. So it is always wise to at least fix one component of your assembly. So that way, if you have mates or interfaces, they behave correctly. Perfect. At this point, we want to go ahead and let's do a file save. And this is a common warning that you will see in SolidWorks. Rebuilding the document is just taking a look at all of the essentially mini triangles that make up these objects and just making sure that everything's in the correct place and saving them like that. Basically, it just offloads a little bit of computation to saving right now rather than you having to do that when you open it. So go ahead and click rebuild. It'll take maybe 2 seconds. And now we've gone ahead and saved it, and notice that that asterisk is now gone. Congratulations, you have completed your first model and assembly in SolidWorks. Well, you've actually completed 4 models in SolidWorks and now 1 complete assembly. SolidWorks is one of those programs that has a very steep learning curve, but now that you've been exposed to the tools and seen how we can create a fairly complex moving mechanism here of chain links, I hope you feel more confident taking on this software in the future. One final note that I want to touch on before we end the workshop is how to export some of these files. So let's go ahead and one more time just save our assembly here. And now let's say you wanted to create this device in real life. Let's go and open one of our previous chain links and talk about exporting this file as an STL. If you want to edit this file in Mesh Mixer, or if you want to import it into Onshape, or import it into a slicing software like Cura, or Bamboo Studio, or Preform, you will need to have an STL file. So let's just walk through a couple of the settings of how you would do that. So let's go up to File, and we're going to go to Save As. Here, this is actually important because we're using this file in the assembly. So this file is being referenced by other open documents. That open document is our assembly. So what we're going to do is, if we're going to make more changes, we would save a copy and continue, but we can just save as because we're not going to change anything. So let's go ahead, keep it as link 5, and now let's go down and save it as an STL. Now, you might notice some options have changed, and we now have this options box. Let's go ahead and click that. Here, there are a lot of different options for saving STL files, 3MF files, and AMF files. The main thing you want to be aware of is that your file format is in STL, your output is in binary, and then honestly, even though this says unit millimeters, most of the time you change it to the unit that you've been using in SolidWorks, so inches. But it honestly does depend on what type of software you're using to import the STL file. So I would just be aware of this and test it out a couple times beforehand. So if you're trying to 3D print this, maybe create a 10-inch cube, export it as an STL, try unit inches, and then import it into a slicing software and confirm that it looks like 10 inches rather than 10 millimeters, which I hope should be pretty obvious in some of these slicing softwares, but you never know. If you need help with exporting this, please consult resources like Makerspace, because this is their specialty in getting some of these designs from SolidWorks into STL files, so that way you're able to print them. After that, if you have a lot of curves in your model, you can change some of these settings. I really don't recommend it. You could always change it to fine here, and that's better than coarse. And then other than that, sometimes you can click Show STL File Info before saving. But other than that, all you have to do is just click OK, and then just click Save. Say, this is how big the file is, this is how many triangles. And just so you're aware, an STL file is just a collection of triangles, and this is just visually showing you all of those triangles. So yes, I want to save it to users, my name, downloads, link 5 STL. And that's it. You've completed the SolidWorks workshop through Software Training for Students. If you're eager to find out more about SolidWorks, I created a written guide that you'll be able to find on our website or our Canvas course. If you need assistance with finding that guide, please go to our website and contact our managers, or look through our website and see all of the other available resources and workshops that we have for various softwares. If you're still having difficulty with SolidWorks and want to talk to someone about it, feel free to reach out to us and create a one-on-one request. We will do our best to find a trainer who would be able to help, and if not, we can connect you with campus resources who will be able to help you with your design project. Thank you once again for your time and attention, and we hope to see you again soon at Software Training for Students.